All right, we'll get this rolling. I know we started a little bit late, so we're going to dive right in. We're going to quickly go through this process, and this is kind of a teaser. It's going to kind of give you the little skim of what's possible. And really that's what this presentation is supposed to give you, is like that thirst to go to that next level and see what you can do. So we're going to go through a little background. We're going to, of course, have to give a definition. But then we're going to go right through and into the possibilities. Then we're going to talk a little bit about the platform and how it works. So, to follow up on Tim's talk, and we might have that dinosaur, that cell phone. But an interesting thing is we look at the smarts that are in your cell phone. It's no longer just a communicating device. It has smart things like your calendar. It has smart things like your camera, flashlight, all the other apps. But each of these are just smart little pieces. But you can see how technology, when it changes, you have to keep up. Now, to follow Tim's talk, we need to keep up in our engineering profession. We obviously kept up with our smartphones because no one really has the flip phone that much anymore. We even replaced my mother-in-law's this weekend because it dropped into a glass of iced tea. So it didn't work too well. But we're going to talk about how this changing, is driving change in our buildings. Just like all those pieces have been replaced by a single device, we see a lot of changes. So we look and say, what is an intelligent building? We talk about it's transforming. You want to get recognition. But most importantly is you want it to be smart systems connected together. Now notice we haven't actually done anything that's intelligent yet. We just have smart things. We need to converge the platforms. Data sharing. I know there's standards on data sharing, but we're talking about sharing across many different systems within a building. But when we get down to the bottom, we have this visualization and user portals. We need that experience. The challenge is, our industry is now competing against some massive companies that are doing things that drive an experience, that make things easy, make things more efficient. Everything we do, we compare to something else we use. How can we compete with Google, Facebook, Apple's interface for our buildings? We need to make it be as intuitive so our building engineers and our occupants can get that same experience. So one of the things we're going to talk about is we have these building blocks. And this slide's kind of interesting. As we started to put it together, we said, what are the smart systems in a building? And at first we came up with like 5, 6, 7, 8, and then we kept finding more and more. And what we realized is we have so many smart systems, our buildings are becoming dumb. It's like when you look at your smartphone and you say, well, I got to find that app. Oh, I can't find it. I've got 5 pages of apps. It doesn't talk to each other, and my calendar doesn't pull up other devices. So we have all these smart things, but they don't really work together. So these are the building blocks, though, that we can use to get to intelligence. We have your life safety, fire, access control, HVAC, some of the basics. Some newer things like digital wayfinding, parking, user portals, geolocations. Taking these and having them work together, you get some really cool possibilities. You can kind of steal information from one system, share it with another, and then share it with another, and make each of your systems become intelligent. Because now you're taking smarts from one system and making another one better. And the whole thing we're really trying to drive is outcomes, is experiences. And that's what we're looking for, because we're competing. And one of the things that's interesting, we're working with one of our clients and they said, well, we want to do an intelligent building. And we said, why? We're losing new hires. Just as Tim mentioned how the internship program is so important because we're trying to find staff. There's a shortage of talent. So they said if we can make our building intelligent, demonstrate that we're sustainable, we will maybe get that next 1 or 2 people to come work for our firm instead of our competitor. So it's interesting how we're now seeing the things that we design and do, what it's being used for, recruiting, not just temperature control. So we're going to go a little bit why, and we kind of have this new triple bottom line. And it's kind of the 3 E's. We have economic, environmental, and this new one, the experiential. And with these, we have the basics in the economic. We want to save money. We want to have competitive advantage. We don't want to waste money. And I put this one up here. I still have this future-proof. Now, anyone notice you can't buy a waterproof watch anymore, can you? Maybe it's the lawyers that came in and they said your watch is now water resistant. I don't think you can make anything future-proof. And I don't mean to pick on Tim, but when he was using a slide rule, he would have no way to prepare that there's going to be a device that'll have his calculator, calendar, computing power, everything in a single place. So you can't really make it future-proof, but you want to make it future-ready. So we're seeing a lot of designs, and our designs are becoming more modular so that they can incorporate enhancements. In the environment, one of the things that's interesting is a lot of these things in the environment category, they really drive right back to the economic. Everybody wants to be green. But if it costs more money, do you want to be that green? So I want to be green, and oh geez, if I can save money, it's great. And we were talking with somebody who said, oh well, wind power is wonderful, but it doesn't pay off because we don't have enough wind. Okay, so do you want to be green or do you want to save money? So what we see is we find ways to take these items and drive these elements so you can really get the economic and environmental. But this next one is where we're really driving, the experiential. And I was reading about a survey that a group did, and they were doing it for an HVAC, and they were talking about comfort. And the data wasn't making any sense. And what we found out is something has changed. Comfort is no longer just temperature. It's emotional. Do I feel safe? When you send your kids off to college, you ask like, well, what is the security at the facility? What do they do? When your kids are at school, they need emergency responses, communication, text messages. If your kids are in grade school where you even get text messages like, oh, this happened at school. The communication, the comfort is now just emotional and temperature. We almost take for granted the temperature because we do such a good job of it. But we need to make sure we have the empowerment, transparency. Now, how many people have put a fake thermostat up where someone was complaining that it was too hot or cold where they were at? That's that power of empowerment. That person now thinks they're controlling their environment, and you know what? They feel better. They haven't changed a darn thing except in their mind. We can do more things like with an underfloor air, we can actually give swirl diffusers that will let them really change their temperature in their environment. But that empowerment is what we're looking to do. That transparency to give them that ability to see where they're going. And most importantly, productivity. If you can make your occupants of a building 1% more efficient, over the life of that building, they'll pay for the building. And that's an amazing thing. So we're going to talk about some of the experiences that you can get. I'm just going to flip through some of these things, and what you'll realize is a lot of this we can do, but how can we do it better? How can we do it more intelligently? How can we do it cheaper? So, we have our basic systems. We have the energy management. And one of the first things you take a look at is all of your newer energy management systems, what do they have? Visualization, they have graphs, so you can see it. It empowers the operating engineer to make better decisions, to compare. Everyone is competitive. And if you can see, what am I doing now as opposed to what my budget is? Am I dropping or below, above? Am I normalizing it for weather data? If it's a warm spring, you might look at your utility and go, oh, we're doing horrible, we've got to fix something with our chiller, something's not going right. No. Normalize the data, use the analysis, and show that you're actually doing better because there's greater cooling degree days than the previous year. So try and make intelligent decisions with intelligent data. The next area we have is vertical transport. Now this is getting to be more and more common. People are starting to use their phones or an access card to get places. Tracking people. And people might say, oh, well, I don't like to be tracked, but maybe it's to guide you. If you want to be guided where to go, one of the trade-offs you have is somebody's tracking you to help guide you. But we're seeing a lot of people take the vertical transport systems and they use the destination dispatch. Similar to what we would do when we design our smoke control systems as to where people should go, what elevators open. You scan your card and it will tell you what floor to go to. We'll turn on your office ventilation system. Maybe notify someone you're coming. How to make things work together. Now this is one that I think is very simple to take a look at. We all know how these work. But there's so much data that is wasted in a lighting control system. It tells you the intensity of the sun, the location of the sun. With that, you can do so many things. There was a project we did that had an all-glass facade, which is wonderful as you're a designer. You're like, how am I going to make sure those people are comfortable right next to the glass? And then as soon as the sun goes away on a cloudy day, they're freezing cold. So based on this lighting system, you can have two different patterns for your VAV boxes for airflow aids. You can change where your air moves. So now you can make your HVAC system more comfortable. And people are more comfortable, they're more productive. So you can steal a lot of data from one system and power another. We've also seen them where they take the occupancy sensors, and if you book, say, a conference room, everybody seems to run out of conference rooms. You always need a place to talk. I'm not sure why. Maybe it's just because you order coffee and donuts. But you go there, and if you're not using it and there's no occupancy, they'll cancel the appointment, and then someone else can book that room. So how you can get things to share and become intelligent instead of just a smart system that says no one's in the room and another smart system that says it's booked until 4 p.m. Now this is what I love, it's the power monitoring, and I did see one of our sponsors that had a graphic or a brochure on the smart metering and the capability of doing power monitoring. Just a quick thank you to the sponsors. Without the sponsors, a lot of things in the ASHRAE chapter wouldn't be able to happen, so thank you. But with this power monitoring, you can see so many things. You can look at reliability, but also maintenance. You can take your power monitoring equipment and drive a maintenance management program. You can get digitally tracked runtime. You don't have to go track a meter out in the field. You can tell if it's running at full load or part load based on how much energy it's drawing. Because most maintenance is based on a duration of time or duration of full load. So now you can take your electrical data and drive your maintenance data. Again, how can you steal data from one system to make another system work better? And with we have our HVAC controls. Now one of the things I want you to realize is, real quick, an HVAC control system is already a combination of multiple control systems working together. But look at when we first started in automation, you would have a standalone chiller controller, a standalone pump package. Maybe some room units that didn't even talk to the systems. You had other systems that were on a separate control platform. The building automation industry took those and combined them together into a smart, intelligent HVAC system. So really what we're seeing is we are experts at taking multiple systems and combining them together because we've been doing it for years, to the point now where we just call it a BAS. We don't even realize that it's a whole bunch of other systems talking together. So what can we do with this? And this is one of those things, and I remember about 5 or 6 years ago I was reading an article about nodal analysis and fault detection and how can we improve. And this really comes down to how can we predict where a problem is? How can we eliminate having a person to become upset and say, I need to call the facility and say, why is this not working correctly? Again, anything to improve that experience. So we're coming up with this fault detection, and you can put in rules, algorithms, checkpoints. This device shouldn't be above 75% if this valve is open greater than 5%. Put these logical checks into your building, and with it you can see where there's a fault. One of the things you'll often find is things where if a valve is overridden, you get a phone call and someone says, we've got a room full of people, just chill this room down, open that valve 100%, so they're going to lock it. Maybe lock the fan speed. And then they go, the next person comes on the shift, and they go to another screen on the graphic, and it gets left behind. The fault detection will find that override and allow you to bring it back to where it needs to be. And that kind of leads into monitoring-based commissioning. How many people have ever worked on or read some white papers on monitoring-based commissioning? I think it's one of the newer trends that we're going to see because it goes hand in hand with this thing called big data. If you took a look at older systems, you had 10, 20, 30 points maybe for a central plant that you monitor. Now you have maybe 10,000 points coming back from a central plant. How do you even know where to look? So when we have this fault-based detection and monitoring-based commissioning, you continuously monitor your system. So you're continually monitoring. You identify something that maybe this just doesn't seem right. Let's have an engineer take a look at that and see what it is instead of just going through the 10,000 points. and by the time they finish, they're already late on going back to the first one. So we allow you to focus the effort of your staff, because one of the things you're seeing is, as owners put in more automation, one of the things we're doing, unfortunately, is they're cutting the physical manpower. So we need to make that manpower more efficient, because they're usually less than what they were previously. So this allows you to identify, evaluate, and implement. Now it's interesting, there's that term that blue is the next green. Because water is becoming more and more precious. In certain parts of the world, it's extremely expensive. We've been seeing some areas where we're seeing 25, 30, 40% increases per year in the cost of water from a distribution perspective. So how can we make even our irrigation system smarter? I'm going to go back to electrical engineers in the room. Okay, a couple. We steal so much data from those lighting systems. I love it. We're seeing irrigation systems that are able to take the data from your lighting system and change flow rates, reduce water flow. Do you need to water as much on a day that's cloudy versus one that's sunny? No. So how can we make our irrigation system intelligent, make our building more sustainable, and do our duty as engineers to kind of help the environment? Now the security access, this is where it starts to get a little bit more of, am I being comforted or is someone else watching me? And we're seeing a lot of access control. We're seeing biometrics. Has anyone ever used the eye scan? It's actually pretty neat. I once was going to a site and somehow I woke up in the morning and I burst a blood vessel. My one eye was bright red as the shirt in the back row. And when I got to the site, it was funny, the entire security staff was like, ooh, we got to see if this is going to work, because you don't look anything like you do normally. But they have to scan your eye, scan a badge, you walk in, next room, scan and scan till you enter in. This security is popping up everywhere. But how can we take advantage and steal that data to help others? One of the things is it tracks where people are located. That facility was a data center. So depending on who's scanned in, maybe lights are disabled in other parts of it. You can tie it in with your alarm system. If I scan in, I should only have occupancy and motion sensors moving in a certain area. So we can make our buildings intelligent and steal data from our lighting, security, and our access control to give that extra level of comfort. Now a very strange one, which was interesting, is landlords. And they're trying to figure out where people are located. And there's some major landlords that we're working with that are doing some things where they're tracking when you scan in, and we're actually getting ready to move to the Sears Tower in Chicago. I don't call it the Willis Tower, it's still the Sears Tower, keep the old names. And we're trying to figure out how many seats we need. And it's, we came up with two numbers, and the difference is around $100,000 a year. So it's a significant difference. And we're saying, well, how do we know? So one of our clients came back to us and said, well, this is what we do. We track everybody, and we track and we log how many people from this department are in the office each day, this department, and then we know whether we need to rearrange our staff and our space plan, lease management. So you can see if a group is getting overcrowded, this one management company will go up and say, it looks like you're getting a little crowded, would you like to expand? We have some space next to you. They might go to the space next to them and say, you're at a lower density. Instead of moving out, why don't we just rearrange your space and make it a little smaller? So they're trying to find ways to improve their efficiency of their management of the building. Now cybersecurity, and how many people have had some form of identity theft, be it credit cards or debit ATM machines, things of that nature? I know in the US there's always these massive leaks where they'll say like, oh, by the way, just 800,000 people who shopped at Home Depot had their credit stolen. And it's becoming more and more prevalent, unfortunately. And when you talk to true IT people, they just say anything that can be hacked will be hacked. And we just need to kind of accept and guard against that. But how can we make sure it works? So with our cybersecurity that we add in, and there was a massive leak, and it was one of the larger retailers in the US. The HVAC industry got a bit of a black eye on this one because the leak and the infiltration actually came through an HVAC company's service connection. So when we have 20 or 30 systems in a building, each one of them has a connection point. The whole thing to cybersecurity is to minimize the number of attack points. so that you can do better security. They had hacked in to the HVAC contractor's connection, and they were accessing it for over a month before anyone realized it. Because the HVAC contractor was doing maintenance, when they were done, they left. When they came back a month later to check on things, they noticed something wasn't right, and that's when they discovered it. So if you can combine, you can make things safer by having it more centralized. Now this is kind of interesting, and we've all seen, like in the Mission Impossible movies where they do the facial recognition and they're looking for people and they find them on the street. They've been doing this for a couple of years in stores. Interesting place, casinos. They'll put it up at the high roller section, and if a person comes in that they have a file, someone will walk and be like, oh, welcome back, I'm so glad you're here. The person feels very special, they're welcome, their experience is better. So they'll come back to that casino, because that casino greets them. But we're also seeing where you're doing like trading or banking, where you have very secure information. You scan your card, it checks your face before you can come in. So you might have, if somebody just picked your pocket and has your access card, they can't come into your building. It's adding that extra level of comfort beyond HVAC. And being able to integrate these technologies, they can see exactly who it is, correct the instance, guide them to where they need to go, notify people, change their environment and their space, turn on the lights, maybe open the shades, things of that nature. We're seeing a ton more of this digital credentialing. It's this second level now. I know I personally despise it because every time I log into any bank account or anything, it's that I need new security questions, a new login, I need a new password. Everything is moving to this second level of security where it's some form of a key and then either a biometric or anything for more of a secure location. If you're working in labs, hospitals, this is becoming very important from a patient safety perspective, especially in the neonatal wings and things of that nature where children are, to make sure there isn't things going wrong. They're doing a lot more of these two-factor biometric options. The intrusion detection. Now I have a funny story with the intrusion detection. How do you think intrusion detection can help you with HVAC? I was working on a project, and this was in the Midwest in Chicago where it gets very cold. Sometimes it'll be below freezing for a month and a half. And I got a call that said, we have not been able to keep our gymnasium warm for the last 2 months. And I went out there, and we're walking around, and I'm talking to the operating engineer, and we're saying, have you changed anything? What have you done? And they're like, oh, well, we increased the fan speed. We raised the set points everywhere. We checked the combustion in the direct fired burner. We checked the flow rates. We were checking distribution, but nothing is working. And I said, well, when did you do this? And we pulled up the logs. And I said, is there anything else that changed? Maybe about this period, because that's when the temperature appears to have changed. And all of a sudden the operating engineer goes, oh, there's been an alarm in our alarm system that the window has been open. We just ignored it, but what happened is at the top of this building it had a clear story section that was about 1 meter in height, the entire length of the gymnasium. The windows were left open after the person was doing maintenance on the windows. So we were heating this gymnasium and just kicking all the heat right outside. We had a beautiful, intelligent, maybe just smart, security system that said the window was open. We had an HVAC system that was saying, temperature set point not met, supply more heat. These two systems weren't talking together, so they were unable to see that they were basically trying to achieve something that's impossible. So using this data from the other systems and linking them together, what's interesting is hotels, in many cases, and not even high-end hotels, are more intelligent than our high-end office buildings. You open the sliding glass door on your patio of a hotel, it turns off the air conditioning. This school had all the windows open in the gymnasium, and it still ran the air conditioning. So we need to learn sometimes from these other systems and learn how to improve our buildings. The next thing is just the digital signage, and as a visitor here, digital signage is really important for me to figure out where I'm going. And we see it also, if anyone's coming, especially in the hospitals, universities, if you're visiting, you want to make that experience easy, simple. You want people to know where they're going. So we're seeing digital signage is really starting to become a big thing in how it tells you where to go, what's occupied. Scan your card, it'll tell you where your meeting is. Scan your card as you come in, it'll tell you what floor to park on in the parking garage and what elevator to go to. One of the things I don't like is they're starting to link it to this retail signage, so then it maybe will tell you, like, by the way, I go to the vending machine and I get the peanut M&Ms and I track it with my card, so I charge it to a single card. So as I walk by, it might change the vending machine sign to be the peanut M&Ms, so I buy more of those. Maybe take the impact on the waistline, but they're starting to try and help you. But this is the next one. Network, mobility. How many people here can do almost everything from their phone? The ability to maybe not be in the office and play a little hooky and still answer emails and get some work done. That mobility is now the norm, especially for the younger generation. I have an 8-year-old daughter and she's like, oh, well, I can call you wherever you're at. Just let me know when you're on Wi-Fi. She's coaching her grandmother right now and setting up her iPhone. But we need to design this mobility into now our office spaces and our buildings. If you walk into a building and they don't have Wi-Fi, you don't have Wi-Fi here? What's going on? That's the expectation we need. Well, you can take that data and use it to help you. Put that Wi-Fi, use more wireless sensors, be able to change and make your building more modular by using that same network for your HVAC. And this bring your own device is a new trend. Just show of hands, who's Macintosh users in the room? Apple? A couple of Apples. Rest are Windows, Linux. Everybody wants to use what they want to use. And if you've got a great talent you want to hire, and the person goes, I love my MacBook Pro and there's no way I'm going to use anything else. I know how to use it, I know the shortcuts, I know the commands, you're going to give me this little device. I'm slow. Companies are now going to this bring your own device, which when I went to college, BYO was just BYOB, bring your own beer. But now it's bring your own device and plugging into the network. So you need to set your systems up to be that way to allow for it. Which means you need to have a very extensive backbone. We're seeing the IT systems need to be extremely robust because it needs to be able to accommodate everyone working in the library or in the cafeteria or at their desk. So a single person, you need to have infrastructure for them to be in 5 different places. As well as you have to have HVAC systems respond to those changing locations. We're even seeing things here, and this is an actual site from the screen. Based on this, density settings, if the density gets too great and there isn't an appointment, it'll show the room as blocked. It will override potentially a set point. If the room has a set point, it'll drive it lower. In some cases, we've even seen where it will pre-cool a room based on the HVAC settings. I worked on a project where it was a massive performance hall and it was supplied air underneath through concrete ducts. It needed to run for almost 45 minutes prior to the performance because it needed to change the temperature of the concrete ductwork. So based on your scheduling and tracking people, you can have your HVAC system be ready. Instead of people walking in and going like, oh, this room is not warm enough, it'll warm up eventually, you can make it adapt and be prepared for you. So we have all these outcomes we're looking at trying to get. And we have that big data. This is the one thing we always got to be careful. Now those electrical engineers, we always have, and for the owners that say, what do you want? Electrical piece of equipment, now talk all over our HVAC systems. And you can say, I like the data from that UPS. It'll give you almost 900 points for a basic piece of equipment. We need to make sure we manage that data because we can't confuse our operating engineers with 900 points on a screen. We need to give them what are the 3 they need. So we really need to take a look and say, how are we going to do this? Now, we've talked about these outcomes. How do we get this? And as I mentioned before, we're finding that in the industry, the HVAC engineers have a leg up over like a Deloitte or other consulting firms that are starting to try and do this, because they've never really combined the systems. We've already successfully done this. These are all the systems you see in your building. Notice each of these potentially is a security risk. Each of them has data that you can maybe share with the other. And we've all been in the control room where there's a dozen monitors in the room. And probably in the corner there's a box with the tape on it still. That's the O&M manuals that you gave when turned over the building. But we want to work on how we can make this smarter. And what we're finding is we need to steal technology from software companies. Build this middleware to help these devices talk. That security system that knew the window was open and the HVAC system that knew it was not getting warm enough, we need those to be able to communicate back and forth. That's why we're looking at putting in this middleware that allows these devices to talk together and share. So with this, we end up putting this middleware which allows for a central platform to do the communication. Single point of connection to the outside world to monitor. One of the key things is if you do have, say, a BIM model, Revit, it makes it so much easier. For new construction, trying to put this intelligent platform together is much easier than an existing building. If you probably pulled the as-built for this building and you went to the mechanicals, the electricals, and plumbing, I guarantee you half the rooms have different numbers. C102, C space 102, C-102. To be intelligent, it needs to really drive off the database to check and share knowledge back and forth. So when we use some of those new standards we have in the BIM and Revit to provide a common nomenclature for all the spaces, it allows you to very quickly put that fault detection into your building, to have it check all discharge air temperature sensors versus a chiller position, instead of having to plug them each in. It allows for you to do future changes you can add onto your building. If you follow that same Revit design standard, you can add on and still have the intelligence. So we're seeing trying to make this converged platform is where we're trying to go. And one of the things, and just an interesting concept, you say, well, this is expensive. The amount of data you can steal and options you don't have to buy in each of these individual systems, we're finding that it's the exact same cost to have an intelligent system as a whole bunch of smart systems. As long as you start early and identify what you can take from other systems. If you can take all of your occupancy sensors and tie them in with your security system and have the same sensor provide that same information to two systems, you've dramatically reduced your cost. That's just one example. And you kind of say, well, this is brand new. Ever remember when we switched our specification numbers? Oh, that was about 10 years ago with the new spec sections. There's a new trend, and one of the things I had was this Division 25 called the System Integrator. And in this specification, it already talks about how it's going to take the data from our fire, plumbing, BAS, metering, lighting, fire alarm, and combine them all together into a single platform to communicate. So this is a case of kind of like variable frequency drives. When they first came out, they were expensive. They were hard to apply in anything smaller than, say, 50 horsepower. They've now become very cost effective. The ability to put the middleware together and the ability to share data and to house data has become less expensive. So now this technology that was known is now becoming more cost effective. So this idea of having an intelligent building that predicts what you want and helps share data, it's here today, and it's going to be getting even better and better as the future comes forward. And then soon it will become the new norm, where your building will know where you're at, what you need, and help have the systems adapt to you. So with that, I'll go. Are there any questions on the intelligent building and the systems? Yes?
When you refer to the middleware, who actually develops this middleware? Is it, you said about stealing the data?
Well, one of the things, and I know I'll just speak from my experience because I kind of know what's inside the black box for what we do. We actually hired a software firm to write and develop the black box engine, and then you can reuse that engine and just kind of adapt it to the systems that are within your building. So you're really just developing a GUI interface and a sharing point that allows for you to take data points out, transfer them. Now in some cases, you will find that the proprietary systems you're talking to only give you read access, not write. So you can't make a change. In that case, you write a graphic that says, check this to the operating engineer or flag an alarm. But we're finding you go to a software provider, and to pay for that software provider, we typically, if you can find enough synergies, you can pay for that additional cost. But it is a software company that writes it, and if you develop a modular engine, you can reuse it.
Are there any known communication protocols for interchange of this data?
We just use the current ones that exist right now. It's really just basic programming language that grabs the data, shares it, databases it, and then runs the checks. It's nothing, I don't mean to belittle it, it's extremely basic.
But
we've been to our software company.
Maybe in the future when it becomes more often this, what you've been talking about, maybe there will be some kind of protocols and standards, because in medicine, for example, in the hospital, there is a communication protocol which enables you to collect the data from the medical devices and to make them communicate with each other. So maybe in the buildings, in intelligent buildings, there will be standards worldwide known.
Well, yes, and one of the ones that we're kind of starting with is coming from the BACnet standards. And that's what we're using as the starting point, but some of the other systems aren't included in that BACnet standard. So I think the next step is to take a, say, BACnet standard and combine it with all the other COM protocols. So one of the things that one of my engineers, what he's saying is the next revolution, as he calls it, is going to be like when we had BACnet. And BACnet was very traumatic to those people that are familiar with it, because it took these 7 or 8 different protocols and combined them into one. We're going to be taking the healthcare protocol, the BACnet protocol, a security system protocol, a fire alarm protocol, and trying to get them all on one. They're not on that platform together yet because it's still the exception, but the norm is coming and it will drive us there.
Within the environment of smart cities, what is now of interest is the need to have buildings talk to each other. Do we have any middleware that would support such need?
There are some programs from a grid perspective that monitor the macro loads of buildings and the simultaneous loads of buildings and the predictive. If this building is at 1,000 kW at 10 a.m., it's going to be at 1,800 kW by 3 p.m. That already exists and is being used by some utilities, at least domestically in the United States. And that's, I think, the next step from the smart cities. The biggest thing we see is from the grid perspective to gather that, because that's the one that's the most stressed. But as we see stress come up on other ones, whether it be from a data perspective, water perspective, or other utilities, that'll be the next area. But right now, the grid programs are being run predominantly by electric utilities.
And we have one final question.
Just continuing the previous question. The new trend in building automation is openness, going into open protocols, like BACnet. BACnet is an excellent platform to build communication between different systems. And, okay, for the systems that we cannot integrate in open protocols like BACnet, like Modbus, like TNX, Longworks, there is an OPC server. There is OPC service, but in this case, it depends to the manufacturer of the system to give the information to the system integrator. General trend is openness, and every company, every vendor nowadays is driving to openness.
Well, and one of the things that we see is we need the openness, because the benefit for this type of intelligent building is to get more systems on it. And that's why we're trying to have it be as open as possible. Also, with the fact is we're seeing the vendors as what we really like as they're being more open, because when they come up with a new version, we can see into it and see what changes we need to make from a continuous maintenance perspective. Because the one thing that you do know, I mean, we all are aware, even just updates on phones and things of that nature, or Office, updates in software occur more and more frequently. And as we get more and more transparency into the software, we're able to keep that intercommunication together. I know in our office, we have a Revit platform, we have a block platform, we have a filing platform, we have one for management of our files. And as we upgrade one of those programs, occasionally Outlook doesn't agree with Office anymore. Office doesn't agree with AutoCAD. So the transparency is what we need to see that. And I agree, we're seeing much more of that.
And one significant thing is in planning in the transition into BIM. This could be the good thing, the good next big thing to do.
I think it might be a catalyst to help them, because it's something that hasn't quite taken off. I wish we did more of it, because it's great, but I think now we have another benefit to having that logical platform for the entire building.
Yes, and it seems since BIM is starting years, that BIM and integrated building systems will eventually become a single point of planning, designing, building facility management, and building automation and control system. I could say total building solution.
I love it. It's exactly where we're going. It's exactly what we've seen in the building automation systems over the last, 20 to 30 years. So, the history will repeat itself, and I think we're coming right down that path. I thank you. I know I've gone a little over in time. Questions?
Yes,
but,
exactly. Thank you.
thank you for your attention.
Thank you very much.